The next thing I'm going to ask you to do on test 4 is to solve 3 games. That is, find the solution, the Nash equilibrium solutions, and then state the solution to the game, and then give the value of the game for row, because as you know, these are going to be strictly competitive games, so the value of the game for column will be the exact opposite for row. Here's the first example of one I give you. This would be an example of one, the difficulty that is about 4, that's worth about 4 points. Okay, let's take a look at this game. First of all, you'll notice, if you look at it from row's perspective, that R2 weakly dominates R1. R2 pays for row pays off better in C1 than does R1, and it pays off equivalently in C2 and C3. So row 2 dominates row 1, and so we know that row is going to play row 2 when we look at it from row's perspective. And so, therefore, column is going to play C3 because C3 will maximize column's utilities to +1, knowing that row is going to play R2. So the solution to this game, using dominance reasoning, starting with row, would be R2, C3, and the value of this game for row is -1. And of course, the value for this game is column is +1. But now look, there's another way that you could have looked at this game. You could have looked at this game from column's perspective and noticed that C3 weakly dominates C1, paying off the same in R1, but paying off better for column in R2. And C3 strongly dominates C2, paying off better in both row R1 and in R2. So C3 is going to be the play that row plays, and you'll notice now that there are actually 2 points in this game that are in Nash equilibrium, both R1 C3 and R2 C3. If they get upon either of these points, neither will have any reason to choose to unilaterally change his or her strategy. If they got on either of these points, row won't, because it'll just stay from -1 to -1, and C won't, because it will go to either the same or a worse outcome. So here was the solution of the game from dominance, and this would have been a perfectly from row's perspective, this would have been a perfectly acceptable solution if you gave me for the game. But if you looked at it first from column's perspective, you'll see that there's actually 2 points of this game that are in Nash equilibrium. They of course have the same value, -1 for row. Either of these answers would have been perfectly acceptable so long as you explain how you got these particular answers.